Hello, everybody. Well done to you all for completing paper 1 of the 2023 Tuition Centre Higher Level Maths Pre. Let's get straight into the solutions and let's have a look at our short questions, our concepts and skills. They're all worth 30 marks, as you know. Let's have a look here at question 1. So question 1 was kind of a sequences and series question leading into induction. We start off here with part A. It says 4x minus 4, x plus 4 and 2x minus 7 are three consecutive terms in a sequence where x is an element of the real numbers. Investigate if the sequence is arithmetic or geometric. Fully explain your answer. So if arithmetic, we know that term 3 minus term 2 is equal to term 2 minus term 1, i.e. there's a common difference, a common first difference. So let's set this up. Let's get term 3. So we know again that this is our term 1, our term 2, and our term 3. So term 3 minus term 2 is there on the left-hand side. Term 2 minus term 1 on the right-hand side. Let's just be careful removing the brackets, but on the left-hand side is going to give you x minus 11. The right-hand side is going to give you minus 3x plus 8. Of course, those are not equal, so it is not arithmetic. Some students would have fallen into the trap of saying, therefore, it's geometric, but no, you had to fully explain your answer. You had to look through it. If it is geometric, there would be a common ratio, or so term 3 divided by term 2 would be equal to term 2 divided by term 1. So 2x minus 7, my term 3, divided by x plus 4, my term 2, would be equal to x plus 4, again, my term 2, divided by 4x minus 1, my term 1. Now, again, maybe not quite as easy to see straight off that they're not going to be equal. So what do? We continue on. We multiply both sides. It's kind of, you basically multiply both sides by the common denominator, which is x plus 4 times 4x minus 4. It kind of looks like a cross multiplication at the end. But once you've done that, it's actually enough to see there that they are not going to be equal, because of course you're going to have a constant here, which is 16. You're going to have a constant here when you multiply through, which is going to be 28, and you're going to have a negative x term on the left-hand side, a positive x term on the right-hand side. You're going to have x squared on the right-hand side. You're going to have 8x squared on the left-hand side. You can multiply that out if you want to be absolutely sure, but you can at that point say these are not equal. So therefore, it is not geometric and it is not arithmetic. 5 marks. Okay. We continue on to part B. The sum of three numbers in a geometric series is 19 and the product is 216. Find the numbers. Now, so this type of question was very familiar in the old course. So similar ones have come up in the last number of years in pre's and in the exam itself, in the real exam. So it's one the students want to be ready for. What you do, the trick to it here is this: it's a geometric series. So typically you could say, like, if you want, you could say the first term is a, the second term is a times r, the third term is a times r squared, and that would work. However, it's actually easier if you say it is the three numbers. If you say the one in the middle is a, the one after that would be a times r, but the one before it would be a divided by r, a divided by the common ratio. So it's one of these tricks that if you know it, it just makes your life easier. So then we can say, well, okay, it says the product of the three numbers. So we'll just call this term 1, term 2, and term 3. So when we multiply term 1 times term 2 times term 3, we get 216. But of course, there we can see the r will divide into the r. And we get a cubed is equal to 216. We get the cube root of 216, which is 6. So a is equal to 6. Knowing that, and using our last bit of information that the sum of the geometric series, the three terms, is 19, well, we can say that's a over r plus a times r is equal to 19. I put in my 6 for my a. 6 over r plus 6r is equal to 19. Multiply everything by the r, so you get 6 plus 6r plus 6r squared is equal to 19r. Bring everything to one side. 6r squared minus 13r plus 6 is equal to 0. Factorize, you can use your guide number, you can use your brackets method, whichever you like. The big X method, the one I learned myself as a student, you get 2x minus 3 times 3x minus 2 equals 0. Two things together, two things multiplied together to give you 0. Either the first will be 0 or the second will be 0. And once you solve that, you're going to get r is 3 over 2 or r is equal to 2/3. Either which way, regardless of whether r is 3 over 2 or r is equal to 2/3, you're going to find that the three numbers are 4, 6, and 9. Because let's just say we'll just say if r is equal to 2 over 3, then if you have a over r, well, we know that a is 6, so you got 6 over r, you got 6, and you got 6 times r. So you got 6 all over 2/3, comma 6 times 2/3. And when you divide 6 by 2/3, you're going to get 9. Then you're going to have 6, and when you multiply 6 by 2/3, you're going to get 4. So you get 964. And the other way around, you get, if you say r is equal to 3 over 2, you get the sequence 4, 6, 9. So my three numbers are 4, 6, and 9, and my answer is worth 10 marks. So we're up to 15 marks. The last part is induction. So when students looked at this question, some people would have ruled it out and moved on, said, no, induction, I don't know how to do that. I don't like that. I'm going past it. However, the students who do know it would be happy to see this one. It says, prove by induction that for any real number, 5 to the power of n minus 2 to the power of n is divisible by 3. So what do? We start off, we prove the base case. So in this case, prove it is true for any natural number. So the lowest natural number is 1. So prove it's true for n equals 1. 5 to the power of 1 minus 2 to the power of 1 is 3, which of course is divisible by 3. So it is true for the base case. It is true for n equals 1. We're going to assume it's true for n equals k. So this is my second step. So 5 to the power of k is minus 2 to the power of k is equal to 3a, where a is an element of the natural numbers. Okay, so we're saying that it is 3 times some natural number. So that is, that is a way of saying that 5 to the power of k minus 2 to the power of k is divisible by 3. And it's worth saying at this point, there are other ways of writing your answer out, which are equally valid. Assuming it's true for n equals k, we're now going to prove it's true for n equals k plus 1. So we're going to replace k by k plus 1. So where I had k, I'm putting in k plus 1. And then what I'm saying is I'm reorganizing this to say, well, 5 to the power of k plus 1 is equal to 5 to the power of k times 5 to the power of 1. It's your first law of indices. 2 to the power of k plus 1 is 2 to the power of k times 2. Now, what always happens with induction, no matter what level you're doing induction at, okay, whether it be here for Leaving Cert or in college next year, whatever level it is, you always use step 2 in the proving of step 3. Okay, so that's always the case. So that's what we're going to do here. So you're always looking to use step 2 to prove step 3. So what we do, and there's always, those of you who've practiced a bit know there's always the last little trick. This last part is where you go from having maybe a high partial credit to getting full credit. So in this case, we have to know that we split 5 into 3 plus 2. Now we'd say, well, why do I split 5 into 3 plus 2? The reason is because it's going to get us to our answer. When I multiply through, I get 3 times 5 to the power k. So I'm going to have 3 times 5 to the power k plus 2 times 5 to the power k. And I'm going to have my, and I better just, that doesn't look, I haven't written that quite the way as clearly as I wanted. So let me just try that one again. But I'm going to have 3 times 5 to the power of k plus 2 times 5 to the power of k. And then what do I have here? I have minus 2 times 2 to the power of k. Now, I'm going to work here now with this part here. I have 2 times 5 to the power of k minus 2 times 2 to the power of k. So what I'm going to do is I'm going to factor out the 2 from that part. And that's exactly what happens here. I've factored out the 2, so I get 2 times 5 to the power of k minus 2 to the power of k. But of course, that is what I had back up here. That I know 5 to the power of k minus 2 to the power of k is equal to 3 times a. So 5 to the power of k minus 2 to the power of k is going to be 3 times a here. So now I can say that's equal to 3 times 5 to the power of k plus 2 times 3a. Now, why is that going to be important? Okay, so that's the same line here, just written slightly differently. I have 3 times 5 to the power of k minus 3a times the 2. So the same line as there, except written the other way around. And of course, all of that is divisible by 3. In fact, I could factorize out the 3 and I get 3 times 5 to the power of k minus 2a, where a is some natural number. And just to be clear, that has to be divisible by 3 because it is a multiple of 3. It is 3 times 5 to the power of k minus 2a. That is divisible by 3. Therefore, I have proven it true, the statement to be true for n equals k plus 1. So I have proven it's true for n equals 1, and assuming it's true for n equals k, I've proven it's true for n equals k plus 1. Therefore, by induction, I've proven it's true for all n an element of the natural numbers. And that's worth 15 marks. So well done to everyone who got that. And now we're finished question 1, and we'll go on to question 2, and we'll see that it's a complex numbers question.